Hello everybody, this is the notes for section 10.4, talking about inscribed angles. Now we've heard this term before, not with angles, but inscribed triangles, inscribed, that's really what we talk about is triangles, or even an inscribed circle. Basically just means you're drawing something inside of something else. So an inscribed angle is just that, it's an angle drawn inside of a circle. Now, some of the details. The main thing that makes it an inscribed angle is that the vertex is on the circle. Okay, that's the key thing to making an inscribed angle. When you draw an inscribed angle in, on the interior of the angle, the part of that circle is on the inside of that angle. That's called an intercepted arc. There is a relationship between these two things. So this is it. The measure of an inscribed angle is half the measure of its intercepted arc. So whatever arc AB is, the inscribed angle is half of that. We're going to do some examples. I'm just kind of going through the notes fairly quickly, so you may be wanting to hit pause buttons to copy some stuff down. But and we could prove this stuff. It just basically becomes some congruent triangles and making relationships between the triangles, maybe some exterior angles. If you want to see the proof, we can do the proof later on, but not worth it in class or in note time. So for the next property, if you have two inscribed angles that intercept the same arc, those angles have to be equal to each other. So the idea of this one is, if you look at angle D, it's an inscribed angle. It intercepts arc AB. So angle D is half of AB, but angle C is also an inscribed angle. It also intercepts arc AB. So whatever this is, this angle is half of that. So is this one. So they have to be equal to each other. Okay? And we could go back to this one, we could go in the other direction. If you have two inscribed angles that are equal to each other, then the intercepted arcs are also going to be equal. A little bit of a different idea, but it applies the same kind of logic to it. All right. The next concept for this section. If you have a right triangle that is inscribed in a circle, the hypotenuse of that right triangle must be the diameter. So the idea here is, looking at this picture, let's say triangle ABC is a right angle, or is a right triangle. Angle B is going to be the right angle. So angle B is an inscribed angle. It is half of its intercepted arc. So that means the intercepted arc, AC, whatever that was, the angle's half of it. So if that's 90, the angle's 90, that means this arc has to be 180. If you have an arc that's 180 degrees, that's a semicircle. So AC must be a diameter. All right, that's the thinking there. The second property here is basically the converse. If one side of an inscribed triangle is a diameter of the circle, so what we're saying now is AC is a diameter. That means this arc is 180. And so angle B, being an inscribed angle, is half of its intercepted arc. That means that's got to be 90. And so you got a hypotenuse, you've got the right angle. All right, I believe this is the last property. So a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So the idea with this one is, if we have this inscribed angle, angle EFG, its intercepted arc is arc ED around to G. Okay, so angle, I'm just going to call it angle F, equals half the intercepted arc, which is arc EDG. Now, so we looked at angle F. We're talking about opposite angles of a quadrilateral. So that is this angle, D. This angle, its intercepted arc, is arc EFG. So angle D is an inscribed angle. It will be half of arc EFG. Now, if you add arc EFG to arc EDG, that's 360 degrees. So half of this, if you just multiply this by 1/2 and this side by 1/2, you have 1/2 EFG, arc EFG, plus 1/2 arc EDG to equal 180 degrees. 1/2 of arc EFG is angle D from up above. 1/2 of arc EDG is angle F, just making substitutions from above, to equal 180. Angle D and angle F are opposite angles. So if a quadrilateral is inscribed in a circle, the opposite angles will be supplementary to each other. And we can do the same thing for angles E and G. Angle E plus angle G will also be 180. But again, notice if and only if. So we can read this in the other direction. It says if the opposite angles of a quadrilateral are supplementary, then that quadrilateral can be inscribed into a circle. All right, that is it for the notes. Next video, we'll do some examples dealing with all these properties. Please watch it.